What's happening, YouTube? This is the next podcast series on an interview between MR3D-Dev and Wildok Studios. Sit tight, relax, grab some popcorn, and enjoy.
All right, now we're going to move on to our next topic, one that I've seen around in the community, like not only developers but gamers love to speak on this too, is the AA discussion. So everybody hates TAA. There's even a Reddit for that. People hate TSR now, and I personally like this is a little bit more technical than the things I work on, but I sometimes think like, what do you want us to do? Do you want your games to have no AA at all? Because they're gonna look awful. Everybody dislikes TAA. You don't like TSR. I've heard some people saying like SMA is it's the worst thing ever. I personally don't like FXAA because I tried that FX a lot in Assassin's Creed games. They used to be very popular in Assassin's Creed games for some reason, and every time I turned that on, the game looked awful. So, what are we supposed to do in the anti-aliasing arena?
Yeah. So um, every AA method is going to have its trade-offs. You know, if we look at TAA, it's a temporal solution on the cusp of the end of the eighth gen. We had what's called TAAU. So it was basically TAA, temporal based anti-aliasing that had adjustable fields. And Epic has like turn it on, turn it off, and quality settings. But in order to get really sharp images, and I would say Scum is probably one of the better implementations that I've played from a UE4 game. You really have to do your due diligence behind the type of game you have. So if you have a lot of foliage, you're gonna want and you are gonna use a TAA method, you're gonna want to like adjust your temporal sample rate. You're gonna want to adjust your sharpening. You're gonna want to tweak your TAA method quite a bit. Thankfully, not everything in DLSS or FSR and these upscaling methods are bad. They come with AA methods. I think it's DNLAA, I think is what NVIDIA is calling their new AA method, which, by the way, is just as sharp as TSR, which is Epic's, AA and upscaling method, but it's about half the cost for, I would say, in some cases, better quality. So if you have hardware offered AA, which by the way isn't new, if you open up the NVIDIA control panel or you open up the AMD, used to be the Radeon control panel or the Catalyst Control Center, and you go look at the AA methods that are offered there, like we've had hardware based AA for the longest. Now, if you go slap MSAA on a deferred renderer, yeah, you're you're gonna hurt. It's made for forward rendering. And early on, these GPUs that couldn't perform really well, it was regarded as the one of the more expensive AA methods, especially when engines were moving over to deferred and they had this G buffer and you had to do a per pixel basically loop over every pixel. Forward renderers, they don't have this problem. You're not chewing on a G buffer. It's a base pass, and that's why it's the preferred method for like mobile games and VR games. And it's your modern day Snapdragons and your modern day cards can handle that really well. But if you start looking at like how do we handle ghosting, there's two ways to go about that. You make your rendering pass heavier, and people are like, what does that mean? How did you make it heavier? Well, in order for you to de-ghost things on a temporal sample, you have to collect velocity data for everything that you're putting into the screen, because you need to know how to like take the edges off of things that are going to smear over that temporal sample. So collecting the velocity data means you can back it out in math on the compute. So you can send that to the GPU and be like, hey, this thing's in motion. It's going to create a blur on the temporal sample, and I need you to filter all this data out. But you pay for that. You have to pay for that for every shader. So people talk about, I think you and I had talked before, and you mentioned Demetrius CMAA.
Yeah,
So that's
CMAA. Yep.
yeah, so that's a non-temporal anti-aliasing method that is closer to something like FXAA. And like you're talking about, like FXAA is a fast approximation AA. It's a screen-based effect. It's done in post. TAA is done in post, but it does it with temporal sampling. But the FXAA method is noisy, and that's probably what you don't like about it, right? It's better used for
Yeah.
like pixel-based games, like something like Valheim or something like Minecraft would probably do okay with it because you're not having to filter out a lot of shimmering. You're not having to filter out like the harsh lines are actually part of the, I guess, the allure of the graphical style that they're going with. But if you're approaching realism and you're chewing on a bunch of Megascan assets and you're wanting to be super super high fidelity, yeah, you're gonna have to use DNLAA, or you're gonna have to use a highly customized and tweaked TAA. You don't take it out of the box from Unreal ever. Don't just turn TAA on and be like, I'm done. That's not the way that's supposed to work. And you can look into options like SMAA. I would say it's a little heavy. It's a little heavier than I would want to pay for AA, especially a post-process method of AA. And yeah, CMAA is cool. Like that's a plugin. It has a lot of customized options for you to test out what you're seeing. But at the end of the day, everything is a trade-off. You're gonna have to play your game, see how something looks to you, ask yourself if it fits the scope and kind of the overall design flow that you want for the style of game that you're doing. If you're using an AA method that does really poorly with like fast moving, high velocity stuff, then you're probably going to want to lean to something that's a little bit more forgiving. Or you're going to just have to tweak the dog mess out of TAA. If you have the overhead on a stylized game like Fortnite, then you could probably afford a friendly FSR that can play nice across all of the GPUs because it isn't until FSR 4 where they're like, it has to be AMD. But if you're not offering the hardware AA method for AMD and NVIDIA at this point in the game, I think you're doing your game a disservice. You probably want to offer DLSS or FSR's AA method. Just don't make your game have to run with upscaling. That's probably
Especially
the best
if
advice.
it's a Twitch shooter,
Yeah,
especially if it's competitive.
yeah. But yeah, there's multiple ways to solve this problem. If you're in forward rendering, you can even use upscaler AA methods, especially if it's a screen space method. The old FSR2 is a wonderful plugin. It's non-temporal and it does a really good job of cleaning up lines. Anyone in this space that wants to get a really clean look, there's a ton of different options. Not all of them are out of the box. You got to go grab the SDK and implement it, but there are ways to get the quality that you want for your game without just going into Unreal Engine's, editor preferences and ticking the little drop down for TAA,
Yeah. So here's a question, because if you were to ask me this question, even though I don't mind graphics in a video game, I would play. If a video game has good mechanics, I'll play it regardless of graphics. But would you or ship a game without AA?
Yeah. Oh yeah.
Really?
I'm actually working on 2 games. On the mobile platform, I've shipped a game with FXAA or no AA, depending on, the aesthetic there is very, very simple. So it isn't like detrimental to have AA. And another thing too is like as your screen resolution shrinks, like on the Steam Deck, right? Your need for anti-aliasing, if you can match the native resolution of the panel, reduces. You only,
Yeah, for real.
so like if you can hit 720p or a little over that, you're super sampling on a Steam Deck, right? So sometimes it's better to super sample and hit a 110 screen percentage to get rid of aliasing if the Steam Deck can handle that, than it is to slap a post-process AA method on top of it and introduce ghosting, right? So
Yeah.
if you look at it the way that like Skyrim handled it, like you could super sample natively with Skyrim. A lot of VR games allow super sampling. No Man's Sky does that. So especially if it's a deferred pass, because they're we're actually able to get cleaner lines by turning AA off and boosting the screen resolution. It's a little heavier, but it's it justifies the cost for that really clean edge versus you turn TAA on in VR and it's a smeared, ghosty, blurry mess. So depending on the game, depending on the art direction, and depending on the panel size, I could justify not
Would you say
having.
depending on the platform?
Yeah, yeah, I could justify not having AA shipped on. Now, it doesn't mean I'm not going to include the option for AA. Like, am I going to give you SMAA or TAA or FXAA as an option if you want to turn it on? Sure. But is it going to be like a requirement for the game or the design decisions behind the game? Nah, probably not. You know, I don't agree with everything that certain individuals say about AA, but I do agree that locking certain effects behind an actual AA method, especially a temporal one, is probably not the best course of action for the industry going forward. We need to have universal rendering methods that can handle things like foliage and hair without needing to rely on highly temporal based solutions. I will say that.
Yeah, I'd say hair is one of the biggest culprits of AA looking awful
Yep.
because of the way we do hair cards.
Yep.
I honestly don't know if that would change if we were using grooms. I personally have never. You know what grooms are, right?
Oh yeah, 100%. Yeah.
Yeah. For people that don't know, grooms is another way to do hairs, kind of like a spline based, and it can be done with limbics too.
Yep.
And
That
it's
was the
very
original way, was Alembic files.
yeah, and it's very expensive. I do it. I've done it in my channel a lot for my metahumans. I would personally never do it in a game, especially if there's furry creatures, because that is insane. But I do wonder how AA works would work with that, because when I rendered and if I use TSR on the grooms, it looks fine.
Yeah. So, it depends on how much you have going on in your scene. If it's like a close cut camera, a groom is fine. Like if you're rendering out cinematics and you're doing sequencer and you're going for that cinematic look and your target is 30 frames a second, by the way, which is perfectly fine for cutscenes. Then you can do inset shadows. You can do like cinematic quality shadows, and you can do grooms. But when you're talking about a dude that you're like 10 to 20 meters away over the shoulder, or you're in a top down experience or whatever, then
Yeah, of course.
yeah, you're going to want to rely on parallax mapping or some form of like shader effect for the fur look that you're looking for. There's many ways to do hair effects or fur effects without having to rely on like more expensive methods. But yeah, that's like back to the subject of metahumans. Like, initially I think they had what, the 2K, the 4K, the 8K. Now they're like low, medium, high. They've kind of changed it a couple of times based on like their quality thing, and then like 5.6 now has it built into the editor. So it's a wonderful pipeline. It's a wonderful tool, but like it's another area where with great power comes great responsibility. You know.
Yeah. Now, and if you want to talk about that subject a little bit, when it comes to metahumans, well, it used to be that you have the three types: the cinematic, the kind of like medium-ish, and then the low. Then inside the metahumans, you have a ton. You have like 8 LODs, which if you go all the way to LOD 8, it doesn't look like anything. It's just a blob. But they've changed since then, and now you're offered different qualities of metahumans, and this is regarding geometry, not necessarily textures, because now you can separate the two.
Yep.
So I could do cinematic quality metahumans with grooms, with like the high poly resolution, which honestly I don't think the metahumans are that high poly to call it cinematic or different from the in-game meshes, because when I look at video games nowadays, and this is all video games, not only Unreal Engine, several of the video games that I've opened the channel, are not even Unreal Engine. Usually, the characters hover over 120,000 polygons, and that's with like gear and all stuff included. And when it comes to the metahumans, when you open the cinematic one, it's not even that high. So that's one of the things that I always wonder. Like, even if developers use the highest end metahuman on their game, they're still within the budget for nowadays. Which I'm not saying developers are using metahumans, because even the Unreal Engine games that I've opened up, they do have the metahuman DNA, meaning they do have the facial rig, they have the overall body skeleton, and they function the same as far as UV and textures. But what I've seen is that developers are mostly using character creator, and this is medium, big, and small.
Yep.
Because I you look at a game like The Altars. I've already talked about that game in the channel. That game is using character creator, but if you look at the facial rig, it looks like the rig of the metahuman. Same thing with Claire Obscure. Claire Obscure, I think it's the best example, because when I open that, is the same skeleton one to one with the metahumans, to the point where I can even retarget animations and they look perfect without much tweaking. But when you go and look at the how the UVs and how the topology is related, this is a real illusion character creator character.
Yeah.
So,
Real,
and
real.
that doesn't mean that there isn't any artist input, because some people, when I mentioned that, some people say like, no, this is not true. There's an artist behind the character. Of course, there's always an artist behind a character. But they do use certain tools to help themselves integrate the whole thing into the engine. So one of the things I always wonder is why, because metahumans have been a while, have been out for a while now, and I don't see many developers using as a tool, other than people like myself and Matt Workman and all these guys that work in like the previous area and the short film area. I've not seen much metahuman used in video games, even though there is a solution where Epic showcase a metahuman, like a super high-end metahuman, going into UEFN.
Hmm.
So they were telling people like, "Hey, look, metahumans work in UEFN. They might work in your game," which I'm pretty sure it's not gonna be that easy.
Yeah. So, I mean, let's be real here. Real illusion is an industry standard. Like, I mean, let's not be hasty. Like Character Creator 4, Character Creator 3, their universal character system, their rigging system, their stylistic like approach to character design. Um, and some people are really old school. Like whenever I got into character design for gaming, like, I would build on the back. I can't even remember the name of it, but it was basically like a human template that was provided for Blender files. Like you would just go grab it. You would have multiple hand meshes. I use iTool for Blender, and eventually you move up in the world. Let's put it that way. You end up working for a studio that like uses very very evolved sets of tools, and maybe it's Maya, maybe it's some Autodesk tooling, maybe it's Real Illusion, but they have a workflow and they have support mechanisms in place and a contract. And they focus usually on a specific type of game. And I will say that I've used a lot of different tools with character creators. I've used plugins out of what used to be the Unreal Engine marketplace, and then I've used Epic's own MetaHumans very early on. I have a plugin written for it that'll automatically make a character because they just provide assets. It's just an actor with a bunch of skeletons and skins. It's not actually a fully playable character. So I created tooling to help people make an actual character from MetaHumans. But if you look at what they offer today, is it better than what they offered last year or the year before? Sure, it is. But if I had to do a one-to-one comparison with Real Illusion's offer, especially like Character Creator 5 and all the things that have come with it, I would say that it's a more evolved and more diverse and complete tool set. Like the types of characters that you can work on, and again, like you said, artist play a huge part here. They're not jumping in the Character Creator 5 and going, I'm going to go with this default dude or this default girl. Like, they use it more like a template, and then they do the art around what's offered to get the unique character that you ultimately end up seeing in the game. And on the topic that you mentioned initially with the triangle count, you got to remember, like, even UE4 was capable of handling, hundreds of millions of triangles.
Oh yeah.
Triangle count, really, if we want to break it down, the vertex shader and the fragment shader for triangle counts, unless you're dealing with huge quad overdraw, it's never really been an issue, especially with the older LOD system where you could just LOD down. And skeletal LODs have been around since like mid version of UE4. So, this concept, I mean, we've seen it in Unity games like, what is it? 7 Days to Die, The Forest, like all of them use LODs on skeletal meshes. So, this has been part of the workflow for some time. Now it creates a little bit of a pop at a distance if you don't manage your LOD grouping correctly, but it's never really been a problem. Triangles, unless you're on a severely limited like Mali mobile GPU, it's not where the cost comes from. Believe it or not, bone updates and skeletal transformations and local versus global skeletal space and like how often are you ticking those updates for any type of montages or animation sequences that you're playing, whether or not those are like asynchronously loaded, that's going to hit you harder than just the raw triangle data. And then the other thing that makes Metahumans so expensive is surface scattering being a default on the skin of a lot of the materials that are offered by that system versus Character Creator. Like the templates that they offer you for like exporting those characters is, you can forego that completely and go with fully stylized characters right out of the gate. And Epic didn't offer that for Metahumans until like this last iteration. Everything that came out of Metahumans was SM6, the highest, material that you could possibly have. Like getting it conformed down into an atlas didn't really have a solid workflow. It was like, what, 25 material channels that you were paying for that thing? Like, how the asset is built and how the data is compressed and how it's planned on executing against the GPU plays more of a role of how expensive that thing's going to be, how many draws it's going to cost, versus like, how many triangles it really is at the end of the day. All right, guys, that wraps it up for this podcast. Stay tuned for more because there will be more coming. Remember to hit that like and subscribe button. Consider joining the Wild Ox Studios Discord. We would love to have you. Go over to MR3D-Dev's YouTube channel and subscribe if you haven't already. The dude makes awesome content. And until next time, happy developing and toodles.